Hi guys, welcome back to another Easiest Pi video. Hope you're taking a break during lockdown, but also now kind of getting into a routine of doing work. And we hope these videos kind of help you to do that. So today we'll be covering log rules. So hi, my name is Max. This will be covering log rules, and this is used in both NCEA level 2, but also continue to level 3. So if you're in level 2, it's just really good to get a grasp of them now, get a grips with them, because they come up again and again, and they'll be in questions. So the main reason we learn log rules is because they're everywhere. If you are taking economics or chemistry, you'll see these pop up, and obviously in maths. For example, we've got the pH scale. This is logarithmic, and they're just a great way to express large numbers. But one of the main reasons we learn them at school is because of exams, and these appear in exam questions a lot. There'll always be a question on them. So it's just great to learn about them. If you want to learn more about, the applications of log rules, you can go to the mathsstackexchange.com, and there's always posts on there about how these are used and why you should learn them, and also helpful practices. So there are two different types of logs. You'll see log, which you are probably familiar with, and then one which you're not so familiar with, and that's ln. And this is natural log. And sometimes, well, I call it L or ln, but natural log or ln is fine. And we're just going to spend a couple minutes going over the differences between the two, because although you might get some people saying they're the same, they are very similar, but we've got to know the differences. So what you're normally used to is a log x, and this means a base 10 logarithm. So when dealing with logs, you kind of got to know that it's the inverse of an exponential, and we're not going to cover these in this video, but I'm assuming you're comfortable with that. So for a log x, the inverse is 10 to the power of x, and vice versa. So the inverse of 10 to the power of x is log x. But with a natural log, we get rid of this 10, and it becomes a base e logarithm. So e is a weird number, goes on and on. It's around 2.7, on and on. You can research this a bit more if you want to. And we can see that e to the power of x is the inverse. And obviously, once again, the inverse of e to the power of x is natural log of x, or ln x. So you might get these. Normally in level 2, there'll be a log question. In level 3, you might start to work with natural logs. And in other classes, economics, chemistry, and physics, especially, it's just good to know the difference between the two. It just helps a lot. And we can see these are graphed on Desmos. Desmos is a really good tool for in level 2 and level 3 calculus to check graphs and functions. It's really helpful. So we can see the red line is the log x, and the blue line is the natural log of x. And we can see they kind of follow the same pattern, almost like a square root. One really, really important note to take away is that you see these these are never negative numbers. So x is never going to be negatives. The domain, which is the x values it can take from 0 to infinite. And then the range, which is the y values it can take, although it may not look like it, these two functions can actually be from negative infinite to positive infinite. But just the main thing to take away is that these can't be negative. The x value can never be negative and always has to be positive. So the 3 rules we're going to kind of go over today are the main ones that are used in exams. And this image below kind of shows the relationship from logarithms to exponential rules. So if you're comfortable with exponential rules, it's kind of easy to translate it onto log rules. We can see that if we have 2 powers, they add when we times the base together. This is a product rule, and then below we have the quotient rule, and this is just what happens when you divide. And you may have seen this in another differentiation video, but yeah, product rule is just always multiplication, and quotient is division. So these are kind of the 2 main ones you'll see in the exams. The third one is good to know, and and it is used in exams as well. But for now, we're just going to cover some questions. So just remember that calculus is all about practice. This video isn't going to be going over tons and tons of questions. There are resources out there. You can contact your teacher or DM us right on our Padlet, and we can help you out with those, or you might have a workbook. There are many options, basically. So we're going to start off with a question. This is question 2 taken from level 2 algebra last year in 2020. And question A, we'll start kind of simple, and this just shows how we apply these rules. So the question is, write as a single logarithm in the simplest form, and that is log 9y plus log 4 minus log 3y. So you may be tempted to collect like terms. You see you've got a 9y and also a 3y, but I'd advise you to kind of stop, take a look at the question again. We can see we've got 3 logs, and we can see we've got our addition and subtraction. So we know we're going to have to apply these rules somewhere. And this is just kind of a step-by-step way of thinking of how to do it. So let's start with the addition. So we've got log 9y plus log 4. Now, if you remember from our rules before, when we add, this multiplies whatever's inside the brackets of the logs. So we take log 9y plus log 4, and this becomes log 9y, in brackets still, 9y times 4. 9 times 4 is obviously 36. We get log 36y. So just keep that in your head for now. This is separate. That's kind of solved half the question we've got. At the minute, we've got log 36y minus log 3y. Now, when dealing with subtraction, we're going to have to use division. This is the quotient rule for logs. So, and I'm just going to pop the answer up, sorry. What it kind of simplifies to is log 36y, and that's over 3y. And then with some simplification, 36y divided by 3y, we get 12. So this answers the question. We get log 12, and that's just the easy achieve point. But obviously, you're gonna have to get comfortable with these rules, know which ones apply where. But we'll move on to the second question. So these ones might seem a bit harder, but it's nothing new. So we'll start off with BI. So this uses our third rule from before. I didn't cover it too much, so I'll cover it again. When we have log to the something brackets, and in this case it's 36, this will rearrange to x to the power of whatever's on the right-hand side, which just in this case is x squared, and that gets rid of the log. So that's x squared equals 36. And I'll pop the answer up. So this is from the marking schedule. This is what they've got. And now, if we were to take the square root of 36 to find x, this is obviously 6. So that's answered the question, and we'll move on to II. Just make sure that you don't continue and put x equals 6 into the next equation. Don't rewrite it as log 5 bracket 6 plus log 5 and then 12 equals 4. Just leave it as it is for now, because once again, we can see there's a addition, and that means we're going to have to use the product rule. And that's what they've done in the first line. I skipped ahead, so don't skip ahead right to the end yet. We'll go step by step. So we've got log 5 2x squared equals 4. And that's just from x times 2x equals 2x squared equals 4. And then using that third rule again, the one we've just covered in BI, we get 2x squared equals 5 to the power of 4. And you always have your calculator. Never guess these, even if you think you know them, always write them out. So 5 to the power of 4 is 625. To get x squared, obviously we divide this by 2. This becomes 312.5. And that's a really big point to stress. Always use your calculator for these calculations. These will be the silly mistakes that you make and won't bother checking when you check your whole answer script. So yeah, continuing, we've got x squared equals 312.5. Now, if we were to take the square root, we get a plus minus 17.68. Now, don't get bogged down on all the decimal places. It'll be a horrible number. But like they've done in this question, just take 4 significant figures or 2 decimal places, whatever is comfortable. I would advise not to take just 17. It just shows the marker that you're, it's close, but it's just nicer to write out, 1 or 2 decimal places. And just linking this back to the question before, we can see when they answered it, they got x equals 6. Sorry for jumping back. We got x equals 6. But this didn't include the negative possibility. This automatically rejected it. It said, no, logs can't be negative, therefore x equals 6. And that's right. For some questions, in this question as well, they've just went straight to the positive answer and they've got the mark. But one thing that's really important in the second part is, well, for a start, this is an E question. If you're able to identify that x has to be positive and you get all the other steps correct, that's an E. So it's really worth, getting in your head. We see there's a plus minus option, but this 5th line is crucial. It says x has to be greater than 0, has to be in the domain of 0 to infinity. So therefore, you get rid of this negative solution, and the only solution is x equals 17.68. So that kind of covers today's short video. It's a lot shorter to the ones we normally do, but hopefully it helped. So yeah, now the channel is kind of up and running. Feel free to share with your friends. We'll post more videos as we get more tutors. But yeah, subscribe, share, study, all of that. And we've started a Padlet. So if you have any questions after this video, like I mentioned, if you want any more resources, so we have this Padlet, and it's just basically a place for you to discuss with others or, ask us any questions. If you have any video ideas you want in the future, if you're stuck on a question, if you're even stuck on some SciPad pages, you want us to look over, help you out, then yep, just pop it on here. Or you can Instagram us, and that's easy as pie 2021. So yeah, as always, subscribe, share, study. And we hope this really helped. Just remember to, keep it chill during lockdown, but yeah, get into that rhythm. And we'll be posting more videos soon. So yeah, thank you.